Hello, welcome back to Spark Rise. Today we're going to be looking at hexadecimal basics for GCSE computer science. This is mainly built on the OCR exam board, but should be applicable to all GCSE exam boards. It's great if you are learning the content or if you need a refresher. So let's get on into the video. Please, while you're at it, drop a like, drop a subscribe. It really helps. Hexadecimal sounds a bit complicated. Well, it's actually a super easy way to shorten binary numbers. It's used in colours, memory addresses, and even in programming. In this video, you'll learn how to convert between hexadecimal, binary, and denary. Let's get into the video. Hexadecimal is base 16, meaning it uses 16 digits, 0 to 9 and A to F. Instead of writing long binary numbers, we can shorten them using hex. This demonstrates a rough conversion table between binary and hexadecimal. So we have the numbers 0 to 9 and the letters A to F, which correspond to the numbers 10 to 15. This is a really key piece of information. So if you haven't got this down already, try and get this down. So remember, we can't have the numbers 10 to 15 because they're double digits. So we go A to F. For example, the binary 11001011 can be written just as CB in hexadecimal, and we'll see how to do that in a minute. But as you can see, it dramatically decreases the size you needed to store these numbers. To convert between denary and hexadecimal, we simply divide by 16. For example, let's convert 200 to hexadecimal. 200 is our denary number, we're converting it into hexadecimal. So what we're going to do 200 divided by 16, because hexadecimal is base 16. There are 16 possible values in the data set, which equals 12. Remainder 8. If we go back to our conversion table, we had 9, and then it goes 10, 11, 12. And 9 is 9, 10 is A, 11 is B, and 12 gives you C. So we know that 12 is C, so the answer is C, and our remainder is 8, so it's C8. If you haven't understood that, skip back a few seconds, look through that again. The simplest thing is you divide the number by 16, that gives you your first number, and whatever the remainder is gives you the last number of your 2-digit hexadecimal number. Binary to hex is also really easy. You're just going to convert the binary into 4-bit chunks, also known as nibbles, and convert each nibble into hexadecimal. Let's look at an example. This is our binary number. So we're going to split it into 2 4-bit nibbles. We're then going to convert each into denary and then hex. So this is 8, 4, 2, 1, 8, 4, 2, 1. This is our binary conversion table that we always draw out when we're converting from binary to denary. So we know this is 8 plus 4. We know this is 8 plus 2 plus 1. 8 plus 4 gives you 12. 8 plus 2 plus 1 gives you 11. So we can then go back to our conversion table. So we had 10 gives you A, 11 gives you B, 12 gives you C. So 12 is C, 11 is B, therefore 11001011 in hexadecimal is CB. Once again, pause the video, skip back if you need to have a look at that. Hopefully that was nice and easy to understand. Remember guys, there are loads more exam questions on our shorts page, and also you can look at our past paper exam walkthroughs. Now, dividing by 16 can sometimes be quite hard to do in the context of an exam. Example, you've got a big number, you don't know how to do long division, you might want to go for, this is the alternate method. I think this is an easier method, and it relies on our last method we used, using nibble conversions. So we convert our denary to binary, split that into nibbles, and then convert each into a hexadecimal. Instead of going straight from denary to hexadecimal, we're going via binary. So say we've got our number 200. Well, we're just going to write out our conversion table. Split 200 into this. So that gives us 11001000. So then we're going to split that down middle into nibbles, convert each of them back into denary and then into hexadecimal. So this would be 8 plus 4, which equals 12, and this would be 8, which equals 8. Then convert each into hexadecimal. Well, 12, if we remember, 10, 11, 12 is A, B, C. 12 gives you C, 8 gives you 8. And there we go, we got C8 like we did earlier. So that seems a little bit more complicated because you're going for a lot more stages and there may be more margin for error. However, if you are uncomfortable with dividing by 16, I would say go for this method. Once again, skip back, go for it again, test yourself. It's really easy as well for you to test yourself on these own problems, make up a number, convert it to hex, check it with your teacher or in generative AI. So we're just going to briefly look at the uses of hex. You don't need to know too much about this for the GCSE, but I think it really helps to understand why we use hex if you know the uses. So hex simplifies long binary numbers. It's used in memory addresses, error codes, and MAC addresses to make large numbers easier to read and manage. And if you think about it, how long a MAC address already is, imagine if instead of being in hexadecimal, that was in binary, how hard that would be to transmit and to read. Hexadecimal is also used in graphics and web design. It's found in color codes, as you might see if you've done any kind of web design, and for defining RGB values in HTML, CSS, and digital art. Again, if you do any work on HTML, you'll see us using hexadecimal. And again, it's so much easier to write a 6-digit hexadecimal code instead of having to write loads and loads of binary digits. Hexadecimal also helps in networks and debugging. It's used in MAC addresses, system error codes, and debugging tools to make data more compact and reliable. Remember guys, you don't need to know that too much. It's just a good idea to have some knowledge of these key points. So today we learned what hex is, how to convert between number systems, and why hex is useful. If it's helped, drop a like and subscribe for more computer science content or other science content. I'll see you next time. Thank you for watching Spark Revise. Have a good day.